Today we'll examine the inverse normal distribution. So last class we saw how to determine probabilities from a normal distribution using the binomial CDF function. And today we'll work backwards to determine the standard deviation and mean if we're given the probability. So for example, let's say we've got a company that fills cartons of juice to an average value of 150 milliliters. So the average is 150 and the standard deviation is 5. Now 5% of the cartons are rejected for containing too little juice. What's the cutoff point for the minimum volume of a carton? So if we go over from the midpoint, 1 standard deviation, then in between those 2 points we've got 68% of the data. So 1 standard deviation to the left, 1 standard deviation to the right covers 68% of the data. We go over 2 standard deviations to the right or to the left. That's now 95% of the data. So another 5 milliliters in both directions gives us 95%. And then a third standard deviation, another 5 milliliters in both directions gives us almost 100% of the data. So here we're graphing the probability versus the volume. So 5% is rejected for containing too little juice. So just looking at the basic standard normal graph, you can see that if you're less than 2 sigmas, then that's 2%. So we need just a little bit more than 2%, maybe going a little bit into this region here. Then it would be about 5%. So we can shade that amount on the graph below. So we need definitely between 2 and 3 sigmas, and just a little bit more. So using that, you can kind of estimate where you think the cutoff point should be. It looks like it's just a little bit bigger than 140, maybe about 141 milliliters. And now we'll check. So the way that you can find out the value is using what's called the inverse normal. To use the inverse normal, first thing that you put in is the probability as a percentage. So we'll put in 0.05, and then the mean, 150, and the standard deviation, 5. To get to the inverse normal function, you're going to go to your catalog, second 0, hit the x squared button because it has an I above it to jump down to the I section. Go down to inverse normal and put in the probability 0.05, comma 150, comma 5. And that gives you the value, 141.8. So the guess was really close. If the cartons are less than 141.8 milliliters, then they can't be sold. They've got too little volume. Okay, so the inverse normal function starts by putting the probability and then the mean and the standard deviation. And what it's going to do is it's going to give you a value A. So when you put in all those things, it'll give you some number A. And A is the number on the x-axis. And A represents the fact that if you're adding up all the area from negative infinity up to A, then that total area is equal to P. So P is the percentage from negative infinity to A. So for example, if you want to shade inverse normal 0.16, and it should be, the mean should be 0 for the standard normal, and the standard deviation should be 1. So what this means is that we want to know from negative infinity to where is 16% of the data. So here we've got 2%. Here we've got almost 14%. So 16 is going to be just about up to negative 1 sigmas. 1 standard deviation to the left of the mean. Now if we put that into the graphing calculator, the second enter so I don't have to type it all, look for it in the catalog. So I go 0.16, comma, 0, comma, 1. And I get negative 0.99, so very close to negative 1. And that's telling me how many standard deviations I am away from the mean. So, for example, if z is normally distributed as a function with a mean of 0 and a standard deviation squared of 1, what that means is that if sigma squared is 1, then the standard deviation would be root 1, which is just 1. Now, can I find out which value would give me 87% of the data? So this is saying, where do I have to go? Which value of A would give me 87% of the data less than that point? Okay, and to do that, I'm going to type in the inverse normal function. Start with the percentage, 87%. And I've got the standard normal, so my mean is 0. My variance, or my standard deviation, is 1. And I can kind of guess that from my basic graph as well. So up to the midpoint, I've got 50%. If I add another sigma, I have 84%. So I'm just a little bit more than 1 sigma, maybe 1.2 or something like that. So 0.877, comma, 0, comma, 1. 1.16, about 1.2. Just a little bit bigger than 1 standard deviation. Now, this time it's asking for z to be bigger than a. So I want some value a, so that if I'm bigger than a, then I have 20% of the data within that range. Well, unfortunately, the inverse PDF function, this inverse normal, only works for finding values that are lower than a, not greater. But I do know that if 20% is lower than a, that means that 20% is higher than a, so 80% must be lower than a. So I could be clever and type this in as inverse normal of 80% with parameters 0 and 1. So 80%, mean of 0, standard deviation of 1, gives 0.84. 0.84 sigmas. And finally, the last one is saying, this time I want to find a value negative a and a value a, so that in between those 2 points, I have 42%. Okay, so that's probably very badly drawn. Let me draw my normal curve first and then my points. So my normal curve, like that. So I want 42% of the data between 2 values, negative a and a. So they're both the same distance away from the middle. And if I go between those 2 values there, then I need to have 42%. Well, again, this doesn't work very well with the inverse normal, because the inverse normal only goes from some negative value up to a. It doesn't help me with finding values that are between 2 points. But luckily I can use some common sense here. If I've got 42% in the middle, that means that what's left over here and here would be the opposite. 100 minus 42 is 58%. And because this is symmetrically distributed, A and negative A are the same distance away from the middle, that means that the blue portion is just half of the total red portion. So the blue would be 58% divided by 2, so 29%. So now I can use my inverse normal to find out where is negative A. Negative A is 29% of the way in. My mean is 0. Standard deviation is 1. So now I put in 0.29 with 0, 1. And I get negative 0.55. So that means as long as I'm between negative 0.5533 and positive 0.5533, that this should be 42% of the data. So if I want, I can verify that using what I learned last class. So do second catalog, go down and choose your normal CDF again, and then we'll go from negative 0.5533 to positive 0.5533. I guess it should be actually 0.5534. And then you can see I've got 42% of the data. Okay, so you can always check your work with these questions. Now, given that x is a normal with a mean of 15 and a standard deviation squared of 9, find out which value x do we have to go to so that we have at least 75% of the data. So the middle is 15. So the answer is going to be something a bit bigger than 15. So to do this, we'll do the inverse normal. First thing we put in is the percentage that we want. We want 75% of the graph colored, and then the mean, and then the standard deviation. Now quite often what people will do will put the number 9, but remember that when they write the normal function that this number is not the standard deviation but the standard deviation squared. So sigma squared is 9, which means sigma is 3. So make sure you've got the standard deviation there of 3. So inverse normal, second enter, second enter. I want 75% of the data between with a mean of 15, standard deviation of 3. So that means I need to go up to 17 in order to get 75% of the data. Now, quite often on the IB exam, you're going to see questions where they don't give you the standard deviation or they don't give you the mean. You have to calculate those things, which is really difficult for using the inverse normal and the normal PDF and normal CDF functions, because all of those require that you input the mean or the standard deviation. So in example 4, we've got stacks of potatoes with a mean weight of 5 kilograms. We found that there's 10% of the bags over 5.2 kilograms. Can we use this information to find the standard deviation? So right now, if we draw the graph, we've got the middle at 5. And then if we go to 5.2, then 10% of the potatoes are above that value. So now if we try to do this with the way that we've been doing it before, we could do like the normal CDF function. And then for that we would have to put in, let's see, maybe from 5.2 to a million. We have a mean of 5, but we don't know the standard deviation. But we do know the answer. The answer should be 10%. Okay, so one thing that you could do is you could just keep guessing standard deviations until your answer is 10%. It's one way to get to the solution, but it's very cumbersome. There's got to be a better way. The trouble is, we can't use inverse normal because inverse normal needs sigma. We can't use the normal CDF because that also needs the standard deviation. But what we can do is we can take this graph and convert it and change it so that it fits on a standard normal. So we can move it around so that the midpoint is 0. And basically to do that, what we're asking is the number 5.2, this whole 10% thing, if we were on a standard normal, how many standard deviations would 5.2 be? Probably a little bit more than 2 standard deviations. So, in order to find out how many standard deviations it is, now we can use the inverse normal graph on the basic standard normal. So we're taking this, we're converting it to a standard normal just to find out what is 5.2 in standard deviation. So we've got 10% still above that point, which means that we have 90% below, because the inverse normal function only works with the percentage that's below a certain point. And now we're doing it just looking at the standard normal function. So the inverse normal, we want to know how many standard deviations does it take to get 90% of the graph. It takes 1.28. So this is 1.28 sigmas. So what that means is that 5.2 is the same as 1.28 standard deviations. So it's just a little bit more than 1 standard deviation. So if 5.2 is 1.28 standard deviations, then how much is 1 standard deviation? If 5.2 is the same as 1.28 sigmas, then how much is the same as 1 sigma? And really, this isn't like 5.2, but it's 0.2 away from the mean. Because here I'm going 1.28 away from the middle, here I'm going 0.2 away from the middle. So really I should be saying from 5.2 to 5. If that distance is the same as 1.28 sigmas, then how much is 1 sigma? So 5.2 minus 5 divided by 1.28 is the same as 0.156. So that means each sigma is 0.15625. Because if I take my number 5 and I add 0.15625, 1.28 times, then I get to 5.2. Okay, another way to solve that would be to use the z-score formula that we had from last time. The z-score is x minus mu divided by sigma. So the z-score is the number of standard deviations. So the number of standard deviations is 1.28. X is the coordinate on the x-axis. We know mu, and we want to find out what is the standard deviation. So multiplying the standard deviation to the other side of the equation, dividing both sides by 1.28, we get the same answer, 0.15625. Now the very hardest type of IB style question is when you don't get the standard deviation and you don't get the mean. So in the last example, we're given a situation where we know that balls that are larger than 2 centimeters and under 1.8 centimeters are discarded because they're too big or too small. So the system found that there's 8% of balls that are too small. So that would be about here, 1.8. In that region, we have 8% of the data. And 5.5% are too big. So they're bigger than 2.4 centimeters. We got 2.4 somewhere around here, and in this region, we have 5.5% of the data. So we know that the mean is somewhere between 1.8 and 2.4, maybe 2.1 or something like that, but we don't know exactly what it is, and we don't know what the standard deviation is. So basically what we're trying to do is we're trying to take this graph and move it so that it's a standard normal. So that the center is at 0, 0. And then we want to know, if we have the number 2.4, then how many standard deviations is that number? Is it 2 or 3 standard deviations? And using that information, we can find out exactly what the mean and the standard deviation are. Okay, so let's first do the number 1.8 and see how can we convert that to a standard normal. Well, we know that even on the graph of the standard normal, there's still going to be 8% of the data below that point. Do we want to know how many standard deviations is that? How many sigmas? So let's use the inverse normal function. Inverse normal, we want to know 8% is below that point on the standard normal, which has a mean of 0 and a standard deviation of 1. We got a mean of 0, standard deviation of 1. So that's the same as negative 1.4 sigmas. Negative 1.4. So that means we've gone 1.4 sigmas to the left to get to that point. There's my 3 sigma mark. Okay, now we can do the same for the 5.5%. Okay, the inverse normal function doesn't work for values that are bigger, so we need to figure out if there's 5.5% bigger, how much is smaller than this point. So we can do 100 minus 5.5, which is 94.5%. So there's 94.5% smaller than this value here, this A value. We want to find out how many sigmas is that A value. I'm going to guess it's about 2 sigmas. So 0.945, comma, 0, comma, 1. 1.6 sigmas. So let's see, I go 1.4 sigmas and I get to 1.8. If I go 1.6 sigmas, then I get to 2.4. Okay, so 1.8 is the same as 1.4 standard deviations. 2.4 is the same as 1.6 standard deviations. So now I can use my formula for z-scores. The z-score is the x-coordinate minus the average divided by the standard deviation. So for my red point, the z-score is the number of sigmas. The z-score is negative 1.4. My x-coordinate is 1.8. I don't know the middle point. I don't know the standard deviation. For my blue value, the z-score is 1.6. 2.4 is my x-coordinate. I don't know my average. I don't know my standard deviation. But now I can solve these two equations simultaneously. So to do that, I can multiply both sides of the equation by sigma. So So move the sigma to the other side so that I don't have to worry about having any fractions. Now I need to solve one of these equations for mu. So maybe I'll take this one, I'll add mu to both sides, and I'll subtract 1.6 sigmas from both sides. So then I get mu is 2.4 minus 1.6 sigmas. So now I can take this value for mu and put it into my first equation. So negative 1.4 sigmas is the same as 1.8 minus 2.4 minus 1.6. And now I have an equation with just sigma. So I'll expand the negative sign, which will change the second term to positive. And now I'll move all my numbers onto one side and all my sigmas on the other. So maybe I'll subtract 1.6 sigma on both sides, and that'll give me negative 3 sigmas is the same as 1.8 minus 2.4 is negative 0.6. So dividing both sides by negative 3, I get sigma is 0.2. Okay, and then I can put that back into one of my original equations. So I'm just going to take this equation here. It's probably the easiest one. In order to find the average, I can put 0.2 instead of sigma in that equation. And I get 2.4 minus 1.6 times 0.2, which is 2.08. Okay, so now I know my average value is 2.08, which makes sense. It's kind of between 1.8 and 2.4. And my standard deviation is 0.2. So when I go over 0.2, then I have 68% of the data. And if I go over another 0.2, I have 95% of the data. So that would take me to 2.48. That kind of makes sense because I only have 5.5% of the data left over at this 2.4. Okay, so to practice this unit, in your book, look at page 548, numbers 1 to 5, page 550, numbers 5 to 11, and make sure to pick up the review worksheet. We'll have a test on this material on Tuesday. And don't worry, not this Tuesday, but next Tuesday, December the 11th.